And so far I think we have looked at looked at the threads. Fine, we have seen the thread class more or less. There are a few more aspects related to the thread still left out. Okay, one of them is, yes, we have, when discussing, writing all the get methods, properties. Okay, so like what are the various get and set methods? Fine, we have seen there are properties for name. Yeah. Fine, we have name, priority, daemon, whether it is alive or not, ID. Fine, many of these are only get methods, right? Alive, ID. Uncaught exception handler, you have get set. Stack trace, you can get. Fine. We have a state. Okay. Fine. State again only get. Stack trace you can get. Okay. Fine. A few more things here. There's one more thing which you can get. Okay. We have not yet discussed so far. Is nothing but a thread group. So let me put the method name here. So there's another method here called thread group. Okay, so we have one class called thread group, that's fine. Yeah. We have the class called thread group. Okay, so we have a method called get thread group. In the thread object, we have a method called get thread group. So it will give the group to which a particular thread belongs, and this thread belongs to a particular thread group. Okay, various constructors for thread. And before going into the thread group class, we can understand, let's say, the various constructors available for the thread. Okay, so thread constructors, if you look at, we have a no argument constructor. Fine. We also have a constructor which takes runnable, that's the one which we have used. We call it as the target. And we do have a constructor where we can use a name, and so you should be initializing the name with this, and you may also give a runnable target. Or you may use 3 parameters. Okay. You may specify a name. The order of the parameters you'll have to just check, but you also specify a thread group. Okay, the group to which it belongs, and a runnable as well. And so 3 parameters are there. There are other overloading of constructors. For example, you may have name and thread group, maybe. It's combination of these 3 parameters basically. We have other constructors which may be just combination of these 3 parameters. So when you create a thread, you can give the name to a thread. Fine. You can make it part of a particular thread group, and you specify a runnable. Fine. Specifying runnable, So there are constructors which do not require a runnable, even those constructors are available. So maybe a name and a thread group, but no runnable is specified. And even without runnable, thread objects are created. Now if it is created without runnable, then what will it execute? A thread must have some target, and this is what should be done. Fine, the target is specified in the run method of a runnable. So when you are creating a thread, you must have some runnable, right? Okay, so we have constructor where runnable may not be specified. So such constructors are also there. So then where is the runnable? Okay, the thread class implements runnable. Thread is already implementing the runnable interface. Thread implements runnable. Thread itself is runnable. Thread has a run method. Thread also has a run method. Yeah, we saw, okay, runnable has the run method, but thread implements runnable and it has an implementation of run method. Okay. So let's see what is there in the run method of our thread class. Yeah. See, when you pass a runnable object as a parameter, so if I look at an object of thread, and here is some object of thread, okay, it would have name, priority and other things, right? And one of the things which is not available as a get method nor as a set method, but it is there as an instance variable. There is one instance variable, the type is runnable. So it has a runnable as an instance variable. The name of the variable is basically, they call it as target. So there's one instance variable, a private instance variable called target. The type is runnable. Right? When you pass a runnable, this is what is initialized to whatever object you have given as a runnable. So it keeps the runnable which you give in the constructor. Okay. Otherwise, this would be null. Otherwise, this is null. Okay. And another thing is, this thread is already implementing runnable. It has a run method. Thread has a run method. Let's see what is the code in the run method. Fine. Understand, there is one private variable of type runnable. It's known as target. Okay. So the run method which is there in the thread class goes like this: public void run, and it simply says if target is not equal to null. So someone has specified a runnable. If someone has given a runnable, then target.run, call the run method on the runnable, and this is the code. That's it. There's nothing else that run method does. And this is the run method which is in the thread class. And this is what is there in the thread class. So when you actually call the start method on a thread object, right? Yeah. When we call the start method on thread object, what will happen? A new runtime stack will be created. It will be initialized with the run method of a runnable, but which runnable? Not the runnable which you have passed. It's this thread objects run method. See, what's going to be there in the stack? The run method of the thread object. In the thread object's run method, it is in turn going to call the run method of our runable. Right? See, unless this finishes, this is not going to finish. But for that, yes, you must have given a runable. So when we call constructor with runable, okay, it's actually just doing a run on the target, whatever runable we have given. Okay. So now coming to another way of creating and defining your task. One way of defining your task was create a class which implements runable and put the run method there. There you are defining your task, what should be done. Another option which you have, okay, but this is not preferred, okay. The new option which I am talking about is something which is not really preferred. But the option here is, instead of going for a class to implement runable, a separate class, someone could have done a subclassing of the thread class itself. Create a subclass of thread and override this method. This is not a final method in thread. This method itself can be overridden to specify the task which you want to do. Okay, and then you create object of that subclass of thread. Not the thread object, but the object of subclass of thread. So the run method could have been defined in a subclass of thread. The task can be defined in a subclass of thread. And then if you create the object of that subclass of thread and call start method on that, the run method which would be here, fine, the run method will be the run method which you have overridden for the thread class in the subclass. Okay. Fine. So you could be defining your task even in the run method of a subclass of thread. Okay. Fine, but that's not preferred. Okay, what is preferred is you should have a runable class of your own, a separate runable, and create object of that and give it to the thread. Okay, but second option is also there. Okay, fine. Two ways creating a new thread of execution. Okay, so looking at constructors of thread, yeah, we find there's one more attribute called thread group. Okay, fine. So let's look at this thread group class. Fine. In the constructor, you can specify a thread group, and there are some constructors where you don't specify a thread group. If you don't specify a thread group, what will be the thread group? Thread group of the creator, and there is a thread which is creating this new thread group. That thread belongs to a thread group already. It has a thread group, so the new thread will belong to the same thread group. Okay, again, thread groups have a hierarchy. A thread group can have a parent thread group. So thread group belongs to other thread group. Fine. See, this is similar to a directory structure. Structuring is similar to a directory structure. You have a directory, or you call a folder, in which you got files and you got other subfolders. Each folder in turn can have folders as well as files. So you have thread group, which in turn can have child thread groups and thread objects. Each child thread group can in turn also have further child thread groups and objects and thread objects. Okay, so threads could belong to any of the thread groups. Fine, but thread group, let's see. So thread group, how they are created. Let's see the constructors for thread group. Oops. And what are the constructors for thread group? a thread group can be created by specifying a thread group as a parent and a string for the name, or you may only create by specifying a name. You don't specify the parent. If I don't specify the parent, what is the parent of a particular thread group? What's the parent thread group if not specified? When the creator thread is there, who is creating this thread group object, but that has a thread group already. When every thread belongs to a thread group, so the one who is executing your current thread, that current thread's thread group, that is the parent. Okay. You have only get methods for these two things. So you don't have a set name method, you only have a get name method on thread group. And you only have a get parent method on thread group to know who is the parent thread group. Okay, fine. I'll show you the initial picture which we normally have. Fine. This can change because, but when you start the JVM, and initially there are some threads which are already created. Okay, so one of the threads, which is the root thread rather, okay, parent of all the threads, okay, there is one of the thread whose name is set to system. And we have a thread whose name is system. We have a child thread group, sorry, this is one thread group, I am talking about thread. So we have one thread group, fine, like the root directory, we have a root thread group whose name is system, okay, and a child thread group whose name is main. A child thread group whose name is main. Okay. Under this system thread group, there are other threads, okay, which are related to garbage collection, and these are related to garbage collection. Okay, fine. There are threads because it's a thread object. I'll just show. Okay, there's some execution sequence associated with them. Okay, execution for every thread object there can be a execution sequence. Okay, as well as in this main thread group, what do we have? Here also we have a thread, and with its execution sequence, the name of this thread is main. Threads have a name, right? So this is what the initial picture is. Okay, and you get your code is executed here. The main method which you have written is executing here. The other things, garbage collection related things, which are also executing. You could create a new thread. From here you can say, let me create a new thread group. You could create a thread group even under the system thread group. You could create a thread group under the main itself, main thread group also. And then you could create threads which belong to any of the thread groups. Okay, so it's a hierarchical structure. Fine. And constructors, we know the constructors for thread, they can take a thread group. And for thread group, the constructor says, oh, I can take a parent thread group. So that's how a hierarchy of threads can be created. And you can organize threads into a hierarchical structure. Okay. Okay. Now coming to some properties which are part of a thread group. Thread group has a name. Thread group has a parent. So there are two get methods. I am not writing them here, but I'll just say the property is a name and parent. Parent, the type is thread group. Name, the type is string. Okay. Few more properties here. One of them is related to the priority. Priority. Okay. What we have here is, we have a method called, okay, so this is get and set method, and the property here is max priority. So get max priority, set max priority. Fine, that's on a thread group. And initially, okay, the main thread group which is there has a max priority of 10. Okay. Whenever a thread is created, fine, whenever a new thread is created, what is the priority of the new thread? It will try to put it to the priority of the creator thread. Fine. It is set to the minimum of this thread which is being created, may be created in some thread group. If that thread group has some lower priority, so it will be set to the lower of the two things. Fine. So maybe you created a new thread group here as a child thread group. On this, initially it would have been 10, but then you may say, okay, let me make it as 7. Maybe you created a thread group with a max priority of 7. Fine. And then you are creating a new thread object under this. But at the time when this was being created, the priority here was set to maybe 9. Someone said, okay, let me set the priority to 9 on the main thread. And then you are creating a new thread under the other thread group whose max priority is 7. Then the priority of this thread will be 7. Fine, it will be 7. Okay. Other thing to know here is, you have this thread, maybe it was still 10, and you created with this priority, the priority here would have been 9. Fine. If max priority was set as 10 only, we didn't change the max priority. Fine. The thread is executing, it's running. The thread has been created rather. Whether it's running or not will not make a difference here. Okay. But then you change the max priority here from 10 to 7. That does not affect the priority of this thread. Okay. Okay, let me tell you what exactly is the point when the priority gets set, how the priority is getting set. On a thread object, a priority will change only when someone calls a set priority method. From the constructor, the set priority method is invoked. Otherwise, you are explicitly calling set priority on a thread object. Okay. So when you are setting the priority on a thread group, that would not affect any of its child threads thread priority. no child thread's priority is affected when someone calls set max priority on a thread group. When you create an object at that time, of course, set priority is called by looking at the current thread's priority. Okay, and the point when the priority changes, how the initial priority is set is something like this. Okay, so max priority is a setting in the thread group. Fine. Okay. In thread group, there are other things also. For example, okay, thread group has a method called, so a few more methods of thread group. There's a method called destroy. Thread group has a method called destroy. Yeah, when someone calls destroy on a thread group, what does it mean? It will? No, it doesn't affect anything. Yeah. No, it will not kill a thread. Yeah, destroy. Okay, so when someone calls destroy, if this thread group has no running threads, if it has no running threads, then only destroy will be successful. If there are no threads which are executing under this thread group, and they have done their job, okay, in that case, calling destroy will work. Otherwise, destroy will fail. Destroy means after the destroy, no new threads can also be, you can't create new threads under this thread group. Object will be there. Object is not getting deallocated or destroyed, something like that. Right? It's not that way. Okay. When the destroy doesn't mean it is going to destroy the object. It is just like maintaining a Boolean value inside a thread group that yes, this is currently a destroyed state. The state is a destroyed state. For the thread group, the state is destroyed. But for that destroy to succeed, yes, it should not have running threads under it. Fine. Otherwise, destroy would fail. It will throw an exception. You're destroyed. Fine. It's not in that state. Okay. We have a get set method here. There is a get and set method for. So there is a setting called daemon. So I'll not write get set method names. Just like we had daemon setting for thread, there is a daemon setting for the thread group. So get daemon, set daemon. When the meaning of daemon here is slightly different. Is daemon, set daemon. It's the same method, sorry. Is daemon and set daemon. Is daemon, set daemon. It's not get daemon. Is daemon and set daemon. It's a Boolean. Okay. The meaning of daemon here, how it works basically. So maybe there is a thread group which is still having some live threads. So destroy would not work. And destroy would not work. And in such a case, what you could do is you could say set daemon. You could set daemon to true. On a thread group, if you set daemon to true, what would happen is now, because there are still some running thread, you can't destroy it, right? It's like marking it for destroy. Set daemon is like marking it for a destroy. once the threads which are running, they have finished, this automatically becomes destroyed. Okay, so set daemon means it would automatically get destroyed once the running threads have finished. Okay, fine. You can think of marking for destroy. Okay, daemon, setting a daemon is like marking it for destroy. Okay, fine. Other thing is about the thread group now, coming back to the thread group, fine. So in the thread group, it's a group of threads. There are a number of threads under a thread group, and even there are child threads which are under its child thread groups also. The entire tree is there. So on any thread group, you can do some method. You have some methods which are also methods of thread. Okay, the idea here is you do it on a thread group, it will be done on all its child threads. Okay, okay. Now most of these here, these group are now deprecated methods. Oh, we had those 3 deprecated methods. Oh, they are here. So you have a method called what was it? Suspend. You have this method called resume. You have the method called stop. Okay, so calling this on a thread group would mean doing it on all threads for this thread groups. Fine. So whatever threads are there under this thread group, on all of them you are calling suspend. On all of them you could be calling resume, or you could be calling a stop on all of them in one stroke. Fine. And there's still one more, so which is not. There's still one more group method, fine, which works on all the threads under this thread group. There's a method called interrupt. So you could call interrupt on a thread group, which would mean calling interrupt on all the threads under this thread group. Okay. Fine. So these 4 methods are working on the threads under the thread group. And they would work on all the threads under this thread group. Okay. Other thing one of those things which is the thread group implements uncaught exception handler. So it has the method called uncaught exception. Fine. Where a thread and throwable, 2 things will be available. Fine. Where we understand by default it is doing a print stack trace. Okay. Okay. On a thread group, you can find all the child threads under the thread group. Oh, what are all the child threads under this thread group? But the ones which are alive. You might have created a thread under a thread group. The thread has finished its execution. No, that's not going to be listed here. The live threads only. Okay, how to get them? So one is we have a method for getting the count. Active count, yeah. We have this method which returns int. Name of the method is active count. So thread group has a method called active count. Okay, and we have a method to return, not return, it again returns in, another method returns in is a method called enumerate, where the parameter would be a thread array. Okay. Okay. Active count, so it gives all the count of live threads under this thread group. Now, the active count is something which you can use to allocate an array of threads, and you pass that as a parameter in the enumerate method. Okay, so when you pass an array, whatever array you are passing as a parameter to the enumerate, it's populating it with the live thread objects. These are the live threads under this thread group. And so this way you could get all the threads which are under a particular thread group. Okay, but anyway, we don't use these methods now, right? Because we know we have the method called get all stack traces. It can give me all the threads, right? And for any thread I can know what is the thread group, parent thread group. Fine. So, yeah, can you think of how do we organize threads under thread groups? I want to get all that. So I want to see all the thread group objects which are there with their corresponding list of thread objects. By using some method in the thread. I am not talking about this thread group currently. By using methods from thread.
Stack threads also.
Yeah, get all stack traces. Yeah, that can be used. So what's the code? So maybe you want a map of thread group, and thread group wise list of thread. Fine. Okay, this is what we want. Okay, I'll say group wise threads equal to, yeah, how do I get this? Thread dot get all stack traces. That's going to give me a get all stack traces. What does it give? It gives me a map dot key set that gives me all the thread objects, and this gives me a thread object. Okay, fine. So it's a set of thread. Right? Key set means I get a set of threads. On that you can use stream dot, sorry, stream is the method, dot collect. You have to pass a collector. And what's a collector? collectors dot grouping by, collectors dot grouping by, parameter to the grouping by will be that's it. Yeah. Fine, so this is something which is easily possible. Fine, so why do we need those methods now? Anyway, see one thing, even the get all stack traces, get stack trace, those methods were from Java 5. These are old methods, active, count and enumerate. Okay, these are old methods. Okay, even we have a static method, the equivalent of the active, count and enumerate. Okay, there's again another equivalent method is like active count. There's an active group count. How many thread groups are active? There's another enumerate where you can pass a thread group array. Instead of thread array, pass a thread group array. So you get all the active thread groups, the ones which are not destroyed. Fine. And what we have static method in the thread. Equivalent, this is here as a method of thread group and it is there as a static method in the thread class. These two are static methods in the thread class. When we use the static method thread.activeCount, we'll get the count of active threads under the current thread's thread group. So static method in the thread class is for current thread's thread group. Okay, so these are also there in the thread class. Okay, finding the active count, but this is something which you can use now, right? Getting this map of a thread group with its corresponding list of thread. Fine. Get a thread and its corresponding list of threads, a thread group and list of threads. Fine, a map with all the thread groups and their corresponding list of thread. Okay. Fine, so thread group is something like this. Okay, so fine, so this was something about the thread group class. Maybe we may have a look at the API quickly. Okay, there are many other methods in the thread group. Okay, let's first look at the constructors here. You have a default, you have runnable and a name. Sorry, the order was different when I had mentioned, right? Runnable and name. You have only the name, or you can use thread group and runnable. You have thread group and runnable and name. Yeah, and there's one more which I'd forgotten, was a thread group, a runnable, the name, and also the stack size, long stack size. Sometimes, very rarely, you may probably need this one. I had used it once. Okay. Normally, the stack size is good enough. Fine, it's quite large stack size, but you can fall short of it. Okay, you can fall short of the runtime. This is nothing but size of the runtime stack. Fine, the size of the runtime stack. See, what happens is something like this. See, this is nothing but size of the runtime stack. So we have a runtime stack. Fine, we understand we have run method, it is invoking some other method. Now if you use a recursion, normally our method invocation levels don't go very deep, right? But suppose you are using a recursion, what will recursion do? Calling itself. So there will be one more frame for itself, and this in turn may be calling. Fine. If that end condition of the recursion is not met easily, fine, may take very long time, it would have grown very fast, fine, and very far. Fine. The usage of the runtime stack can consume the whole, so a recursion can be there which can actually consume the whole of the runtime stack. Fine. You are sure that your recursion is not going to have a failure. Failure in the sense, it's not going to go in an infinite. The condition, whatever end condition is there, it's definitely going to be met if you are sure on that. Fine. And you find that my thread is failing by giving a exception related to the runtime stack. Fine. In such a case, you might like to create a thread with a large runtime stack size, and that's where you get control over the size of the runtime stack. Okay, fine. So you can take control of the size of the runtime stack like this. So that's a constructor where we can pass even the size of the runtime stack. Fine. So we have this constructor here. Okay, fine. Or you have a constructor with thread group and a runnable. Fine. We can go to the methods. Sorry, fine. Still with the constructor. Let's go to the thread group. Fine, and look at the methods here. Thread group. The constructors for thread group. Fine. You can specify a parent and a name or just the name. Fine. As far as methods are concerned, yeah, we have the active count, the active group count. Fine. Allow thread suspension. It's a deprecated method. That's any check access. Fine. This is related to security, and this fine. We have the destroy method. Destroys the thread and all of its subgroups. Fine. This group as well as all its subgroups. Enumerate with a thread array. Now here is enumerate. Fine. I was mentioning one enumerate. Enumerate with a thread array and a boolean value recurse. By default, when I am not passing recurse is true. Recurse is true means, what is recurse for our thread group? Whether to include the threads under the child thread groups. Okay. Whether to include the child threads. Fine. So all the entire tree is to be included, then it is true. If only this thread group itself, but not the child thread groups to be considered, you can pass recurse as false. And so enumerate with recurse. Fine. So you have enumerate with for thread array, you have enumerate also for thread group array. Fine. There's a get and set for the max priority. There's get set for the name, and there's a get for the parent. There's this group method called interrupt. Okay, fine. Is daemon, set daemon, is destroyed. Like we have destroy method, there is a is destroyed method. Fine. Whether it is actually in a destroyed state. List is a method which will just dump, and it will on the standard output it will print the list of all the thread groups, threads under this thread group. Sorry, it's the thread under this thread group. Okay, you can check whether a thread group is a parent somewhere in the parent. Is it a parent of this thread group? Parent of. So A dot parent of B. So B is a thread group which is a child thread group under the A. Okay, somewhere. Right? You have the resume, suspend resume is there, right? Set daemon, set max priority, those two things. Stop anyway is there, suspend is there. Fine, toString, uncaught exception with thread and throwable. And this is because it is implementing uncaught exception handler. And where it is doing a print stack trace. Okay, so this is what is a thread group. Fine, looking at the thread, okay, fine, let's come back here. And so thread group should be fine now. Fine? Okay, let's continue with the things about the thread. Okay, yeah. What we have done in our exercises, we have created a bank server. Okay, fine. So threading looks good. It gives me concurrency. I can have concurrent execution. But then there are some problems related to the concurrent execution. Okay, there are some problems which can happen. Okay, let's consider that a following withdraw method on the account class. So we have this method for the account class. Amount to be withdrawn. Right? So we write a withdraw method which may be something. A simple withdraw method would be doing something like, okay, so you have given me an amount. So you may have that check for negative thing. It shouldn't be negative. Okay, otherwise throw an exception that may have taken place. But then we have something like this. If, right? If amount is greater than the balance, then maybe you do a few more activities before returning false. You want to return a false here. Fine. If it's possible to withdraw, fine. Maybe you do a few more things and then you finally update the balance. You'll say, okay, balance minus equals amount, and then you're saying, okay, let me return a true. Right? So let's assume this kind of a withdraw method. Fine, this is a withdraw method which goes something like this. Okay. Now, let's consider that we have, as an example, we have an account object whose balance is 1500. The balance in the account is 1500. Fine. Now what happens here is, we have one of the threads, our bank clerk here, okay, which is saying, I want to withdraw 1000. I want to withdraw 1000. And there's another one also, almost simultaneously, and saying, oh, I also want to withdraw 1000. I also want to withdraw 1000. There will be slight difference in the timing between the two of them. Slightly, one of them will be slightly ahead. Okay, fine. So what's happening is, we have our first thread doing the checking part, it finds this balance, 1500 is balance, fine, I can withdraw, fine, and it has not yet updated, it's somewhere here. The balance has not yet been updated, and at that time the second thread is doing a check. Update is still pending. The first one, for the first one, it has been decided, yes, you can withdraw. But the updation of balance has not yet taken place. And the second thread checking is being done. Oh, whether he can withdraw. What will happen? Both of them will withdraw. And so this way we can't work this way. See, this part from here, from checking to updation. Fine. While one thread is doing it on an object of account, no other thread should be allowed to proceed in this part of the code. One at a time. Fine, for a given object. Understand, it's for a given honor. On another account, okay, you may do a withdrawal, that's fine, but on this, someone is still using this object, and he is using this code on this object. Someone is using a withdraw on this object, so please stop. How do we do this? How do we achieve this? And there is no mutual exclusion. Lock what? We want the thread to be blocked. That's correct. We want the other thread to get blocked till the earlier thread has done the job. One at a time, right? See, wherever we have any kind of an update taking place, right? Those are the kind of methods where this thing should be used. Yeah? While a deposit is happening, you don't do a withdrawal. You don't do two operations simultaneously, which will involve balance related things, right? Balance is something which is updated. Okay. Oh, you want to change, you want to read the name, you can check the name. Get name method can still be fine. But a deposit while a withdrawal is on that particular object, no, you need to be blocked. Okay, and for this purpose, fine, we call it as a mutual exclusion, right? Okay, and for this purpose in Java, we have a keyword called synchronized. We have a keyword called synchronized. Okay, how it will be achieved? Yeah, we understand, oh, we want one at a time, and that too for a particular object. See, here we are talking about account object. Someone says, no, I have an array. Right? In this array, some update is taking place by one thread. The other thread should not be updating it. Yeah? Right? So it's for that particular specific array object. On any other array object, oh, it's fine. On some other object, you can do whatever methods you like. The thread which is calling, fine, or trying to do something, okay, he is to be blocked. How do we achieve this? So what we have in Java, every object in Java has a lock. There is a lock available in every object of Java. Fine. Wherever we want mutual exclusion, okay, we can ask the thread that for this piece of code, fine, you need to take the lock on this object first. Take the lock on the object first. Okay, use your code and put the lock back. Take the lock, do this part and put the lock back. Okay, so lock is only one. There's only one lock in the object. Fine. So per object, it's every object in Java has a lock. Fine. The object class which is there, that provides lock for the object. Okay. The synchronized keyword is used for taking the lock on an object. Let's see how it is used. There are two uses of synchronized, two ways it is used. You either create a synchronized block, fine, which is a more generic form. So with synchronized, you can say synchronized and specify a target object. Some object may be specified here, and you have your block of code. Okay, you have some more code here, you might have more coding here. So within a method or a constructor or any piece where you have written some statements for execution purpose, fine, what we have is, we can have a synchronized block. The thread which is executing this, see, this is a code, right? Multiple threads may be executing it. This code may be executed by multiple threads. Any thread which comes here, when it comes to the statement synchronized, it is specify a target object. With synchronized block, there is an associated object. So what does it do? What will it do here? This is like saying, so see, thread is looked at like a person who is carrying out these instructions one by one. So he's carried out all this instruction. Now synchronized is an instruction which says, go and get the lock from this object first. This is an instruction which is saying, get the lock of that object. There is a target object, so first get the lock of that object. So this person, fine, who is executing all these instructions, is now going and trying to get the lock of the object. If the lock is available, he gets it and executes his code. And at this point, he will put the lock back and execute further. And take the lock of a target object. Synchronized is just saying, take the lock of that target object. Okay, and then it executes that piece of code. When that code is over, that block is over, puts the lock back. If the lock is not available, he goes for taking the lock, but the lock is with someone else. Then this thread is blocked, and the blocked state is here. Okay, you could have any object as the target object here. You could be having an array object here, right? Because in this code, I am updating some array. Fine. See, look at that thread of execution separately. And this is a thread of execution. Look at him as a person who is carrying out instructions. Okay, synchronized is an instruction to that person. Get the lock first. He gets a lock and then proceeds. If the lock is not there, he is there in a queue waiting for the lock. Oh, there can be multiple persons in that queue who are all waiting for that lock. Fine, clear? Synchronized block. Another use of synchronized is used with a method. It's a modifier for the method. When you have a method, you can declare a method to be synchronized. Fine. A method may be declared as synchronized. For example, fine, we had that, so we could have said, okay, synchronized Boolean withdraw. Fine. Amount to withdraw. Yeah. Okay. Whatever that code is, you can have methods to be declared as synchronized. Fine. When we declare a method as synchronized, and if we declare a method as synchronized, then a method is always called on an object. See, whenever a synchronized use, that means there is some target object involved whose log is required. Fine. So this is like, oh, you are calling a withdraw method on some account object, right? So if you are saying ac.withdraw, whose log will be taken? AC. Fine. So there is a target object whose lock is first taken and then the method is executed. A synchronized method is first will be executed by taking the lock on the target object. Methods have a target object. There are methods without target object. Which are the methods without any target object? The static methods. They are not on objects. Okay. So if you got some static method which is synchronized, it's allowed, okay? Fine. Maybe return type is void, some method m1, some parameters, whatever may be there. Okay. But remember, the method belongs to some class. There is some class called new class, new class within which this is happening. And just as an example, so you have a class called new class which has a static method called m1. So how do we call this static method m1? New class.m1. Fine. How will this be called? It will be called as new class.m1. It's a static method. Okay. So yeah, this is a synchronized method. M1 is a synchronized method. Therefore, some lock must be taken. Which object's lock will be taken? There is no target object which is seen here. Which object's lock is taken? Current class. We have the class called new class. There is a class object for every class. The class object for new class will be the object whose lock will be taken. Okay. So synchronized is nothing but an instruction to take the lock of an object. When synchronized method or the block is over, the lock is put back and the next person waiting for the lock will be getting it, and that's where the blocked state comes. The waiting for a lock is the blocked state. Fine. Blocked state means waiting for a lock on some object. Okay, so what we should do? In the account class, methods we should make them synchronized. Fine. We declare our methods to be synchronized. Method like get name and get account number, they need not be synchronized. Withdraw, deposit, and maybe someone asking for the balance. Oh, there's some update taking place, so I don't give the balance to you. Let that operation be over, you'll get it. So maybe get balance also. Fine, we may put get balance to be synchronized. Okay, print passbook.
Yeah.
Maybe make it synchronized, because if some activity is on, fine, we don't want to print the passbook while something is happening there. Okay, fine. So that way you can take the decision. Oh, these all should be synchronized. Something which is related to updation, right? If there's something which is, if we have an object, if our class is a type where no mutation is allowed, there's no change taking place in any of the instance variables. Once created, it's staying as it is. There's no need of a synchronized at all, right? There's no need of a lock. And we need lock because while update is there, no one should be reading it, or no one else should also be trying an update, and no two parallel updates or reading and writing parallelly on some instance variable should not be allowed. So that's where we have the synchronized. Fine. And understand, it's not locking the object, it is getting the lock of the object. There's a difference. Okay, it's not locking the method. Right? It's only the thread which is executing the method who gets blocked. And thread of execution, remember, it's that person. And always see it from that point of view. And you are writing simply codes. You may have a method which is not a synchronized method, yet while that method is called, the object has a lock, because this method is called from a synchronized method. Synchronized method in turn can be calling a, fine. See, you can look at this kind of a scenario. You look at it from runtime stack point of view, right? You have a method being called. Maybe here is a method. Now I'll take example of a synchronized block here, just for the. Now in this method from here to here, okay, this may be a synchronized block. And from within this there is a synchronized block, but within this he is calling. So if the code, if the execution is here, okay, this guy is calling a method which is here, but this method is not a synchronized method. And the method here is not a synchronized method, but while the method is executing in this current thread, right, it has a lock. You have a lock. Okay. Now you can, for your current thread, you can check whether I have a lock on a particular object or not. Only for the current thread you can check whether you get or you have got a lock on a particular given object, right? So we have a static method in the thread class. There is a static method which returns a Boolean value. Name of the method is holds lock. Parameter is, you can check for any given object. Do we have a lock on this object? I just want to know that. And we have the holds lock. Okay. Yeah. Static method of thread. Okay. And then okay, now coming back to that account example, and we have a withdraw method which we have now made synchronized. Fine, we have made withdraw method to be synchronized. Okay, look at this scenario where we have our account object, fine. Now in this account object we've got some whatever balance may be there. Okay. Now we want a different kind of a withdraw method, slightly different withdraw method, where think of a scenario where maybe you got some cash to be deposited in the bank. Okay, you give it to your friend, fine. So friend says, okay, I'm going for the work and I'll deposit this amount for you, fine. Okay, so later there is some emergency and you go to the bank and you want to withdraw that. Okay, now the idea here is you are not, at that moment it's not sure whether the deposit has actually taken place or not. Fine. Okay, so if you go to the bank and he says, no, you don't have balance, what would you do? You are sure this is definitely going to happen. The deposit is definitely coming. So what do you want to do? You ask the teller, no, I'm ready to wait here, I'm just waiting here. There's some deposit which will come, and when the deposit comes, you can give it to me. Fine. So you would rather than saying, okay, I don't want to withdraw something, you want a withdraw method where you can actually do a waiting for a deposit, waiting for the balance to come up. Okay, you don't have balance, okay, I'm prepared to wait for the balance to be up. Fine. So that can be achieved. Okay, how? Let's see that. So what do we need here is a withdraw method. So I'll try to put the withdraw method, find another version of the withdraw method. Okay, but now we are assuming that we have withdraw, deposit, all of those methods as synchronized methods. Fine, the assumption is it's a synchronized method. So we have our public method is going to return boolean, but it's a synchronized method. Return type is boolean. Name of the method is withdraw. Amount to be withdrawn. Throws and other things are fine. Okay, you may have that check initially for the negative thing. Okay, but then you are having if amount is greater than the balance. Yeah, what do we want to do? If amount is greater than balance, then so this is another form of withdraw now. Yeah, then then wait. Okay, so you do a wait. Yeah, recollect there is a method called wait in the object class. We have a wait method in the object class. Okay, fine. So it's a method of the object class. You may even explicitly say this dot wait. Okay, so you've done something like this. So what is wait method? Wait method means wait for a notification on this object. So withdraw method would do a wait. Okay, on the other side, okay, on the other side you have the deposit method, which is also a synchronized. Returns void. Name of the method is deposit, which takes amount as a parameter and has throws or whatever. Some checks may be there, but then you will have Okay, balance plus equals amount, balance plus equals amount, and then we have another method of the object class being used here. It says this dot notify. Oh, we have a withdraw like this and a deposit is something like this. On this account object, what is notify? On this account object, if someone is waiting, let him come out of the wait. So wait means wait for a notification to arrive on this object. And so wait is nothing but waiting for a notification on the given object. It's a method of the object class. Okay. What is notify? If anyone is waiting, let him get a notification so he can proceed now. You have done a deposit and okay, he can proceed with whatever he was doing. Fine. And here was updation of the balance, right? Here also balance is being updated. Yeah, something wrong with this code? Yeah, your balance is how much? Maybe you have a balance of 5,000. Initial balance is 5,000. Someone is trying to withdraw 50,000. And someone is trying to withdraw 50,000. He is in waiting state. Fine, he goes into a wait state because there is no fine. You only have 5,000, and this guy comes and deposit only 10,000. Your balance has become only 15,000. But when he deposits, you get a notification and you proceed with the, so you come out of the wait and proceed further. And what do?
Check करना पड़ेगा.
So you do not have a wait in the if statement. The wait is normally is going to be a while. We wait while the condition doesn't become favorable. While the condition is not favorable, I'll keep on waiting. Only when the condition becomes favorable, I come out of the while. And my favorable condition is the balance must be there. And my required balance is this much. Unless that is there, now you need to keep on waiting. You get a notification, okay, someone deposits again, then you get another notification, you try it again. Fine. Okay. Clear what is wait method and notify method. But one thing which you are missing here is both are in synchronized. Okay, still another point was wait and notify would not work. They would throw an exception if the thread which is calling wait or notify doesn't have the lock on the object. When he is calling wait, it's in a synchronized, that means he is the lock of the account object. So this is fine. Okay, it's a mandatory thing. For wait and notify, the lock on the object must be with the thread only. Anyone calling wait, any thread which is calling wait must have the lock of that object. Anyone calling notify must have the lock of the object. Okay, fine. So now, first one is in a withdraw, right? First one has taken the lock. For withdraw, he has taken the lock and he is waiting. How will a deposit ever happen? Will he get the lock? See, withdraw is synchronized, lock is taken,
Yes.
and then he is going to wait. Withdraw is not yet over. Where is the lock? Deposit requires lock.
Yes, sir. Yes.
So how will deposit happen? It won't be initiated, na? So look at the wait method now again. Wait method has three parts. There are three things happening in wait.
Yes.
Yeah, what is the first thing?
Time.
Release the lock. First thing, you must be having a lock because you have called wait. And if you don't have a lock, exception. If you got the lock, I'll release the lock now. Put the lock back. And then second step is waiting for a notification on this object. And what's the third step?
Again.
Getting the lock again. And so releasing lock, waiting for notification, and getting lock. That's what is a wait method. Wait has three things in it. And there are three steps within wait. Release lock, wait for a notification, and get the lock back. Then only you proceed further, okay? But you need to, because you are going into waiting state, you need to be releasing the lock. You can't hold the lock and go into a wait state. Fine. And clear? Okay, now another scenario. So this should be fine now, right? With that while loop here, fine. But then we have a different scenario here. We have a scenario where there can be multiple people who will be withdrawing. Okay. So there's someone who is trying to withdraw. So there's one person who is trying to withdraw 50,000, right? Second person is only trying to withdraw 2,000. Second person is trying to withdraw 2,000. There's no balance. There's only 1,000 there maybe. Yeah. So he can't withdraw 2,000. Now comes a deposit of 10,000 or 5,000. The deposit which has come, you send a notification. Who gets a notification? No, not both. Only one.
Current.
Only one. And specifications say it can go to anyone. Okay. The implementations which have been seen, normally the first one gets the notification first. Okay. But you should not assume that. That's the whole idea. Specification is saying it could go to anyone. So you can't write your code assuming the first one will get it first. Okay, that's the whole idea when they say in specification something like this. Okay, but one thing. So what should be done?
Priority.
You want it with notify. It should go to
Priority. Below.
all. Notification should have gone to all
Yeah.
rather than only to one. And that's where we have a method called notify all. Methods in the object class. We have notify all. So deposit, fine. Whenever you do a deposit, okay, just say notify all. Okay. Other thing is, as far as wait method is concerned, fine, wait method has been overloaded so that you can also specify a timeout for the wait. I don't wait more than this much time for a notification to arrive. Fine, so that timeout can be in milliseconds or millisecond plus nanoseconds. Okay. Fine, so yeah, that's the wait and the notify method. Fine, the use of keyword synchronized. See, synchronized has to be used with care because it can also lead to deadlocks. Synchronized can lead to deadlocks. You know how deadlock occur? How deadlocks will occur? See, you got one object A, okay, there's another object which is B, fine. You have one of the thread, fine, which first takes the lock on A, he is called synchronized on A, fine, and then later at some other point he is also, he is not released from within that synchronized, he is also calling some synchronized on B. So he's taken the lock on A first, and then your code will ask it to take the lock on B after taking the lock on A without releasing the lock on A. You want lock on both of them. Okay, but there is another thread who is doing the reverse. He is first taking the lock on B, and then his code is to take the lock on A. What will happen? If the first one has taken the lock on A, he is yet to take the lock on B, but during that time the second thread has taken the lock on B, and later at another point he is trying to take the lock on A. It can't proceed because he is waiting for the lock on B to be released by the second thread. This guy also is stuck, can't proceed because he is not able to get the lock on A. Okay, so be careful when using synchronized. They can lead to deadlocks. The way you write your code depends on that. Fine. So as far as possible, avoid taking lock on multiple objects, and if you have to take lock on multiple objects, fine, then you need to have some kind of a sequencing, or they should always be in this order. If I have A and B, if these are account objects, I'll always take the lock on the lower account object first and then the higher account number later. So have some same kind of a sequencing for everyone. Fine. One thread goes this way, the other thread goes other way. No, then you may it can lead to deadlock conditions. Okay, so you should be aware that with synchronized you can have deadlocks. Okay, now let's update our code. Okay. Time बहुत ले लिया. Fine. So I think what we need to do is update related to the synchronized and wait notify, right? So we just update our methods of the account class. Okay. Okay. Okay, this is what? Has negative balance, it's related to, so this can be synchronized. Get password, that can be synchronized. Okay, and we don't do anything in the class transaction. Okay. That's okay. We have the print password to be synchronized. Okay, since the earlier one is synchronized, this is fine. It's going to call the other one. Constructors are never synchronized, okay? And it's only for methods and not for constructor. That doesn't involve the balance, right? Anything which involves balance, that's where we would like to have synchronized. Get account number is fine. Oh, this one, that needs to be synchronized. Okay. Deposit is synchronized and withdraw is also synchronized. I think, do we have more methods? Yeah. And so that's a change for account class. Okay. And we have to again withdraw method and deposit method also have to be changed, right? Withdraw method. Fine, we want to put the weight here. So here we don't return a false, okay? This one, right? Let's comment it and put this dot weight. Fine, we put a weight here, and in the deposit, fine, once the updation has taken place, we'll say this dot notify all. Not simply notify. It should be notify all. Okay. That if has to be changed to a while. Done. And let's compile. Yes. Okay. Wait throws interrupted exception. Okay. Wait has got throws for interrupted exceptions. That's the one. We can put this in a try catch. Okay, let's compile. Now bank server and 1024, and let's start the bank server. and let's start a client. Okay, let's do a telnet, right? Okay, fine, that's 2900. Fine. Now we have someone to withdraw how much? 5,000 or 10,000, let's say. Oh, from which account? 2011201000 and maybe 10,000. Stuck. Fine. So someone has to deposit first. And this guy says, okay, list, let's see, deposit in 2011201000, maybe just deposits only 5,000, right? Yeah, you have withdrawn 5,000, that's it. Deposited 5,000, okay, it's 7,900, but that guy is waiting for at least 10,000. Yeah? Again deposit, okay. And that guy also gets, right? Okay, so this was, he deposited 27900 and then he is withdrawn. That has happened here. He was stuck waiting for a deposit to happen and withdraw happens now, right? And he is also free to do these things. Okay, maybe he can save this. Fine. Okay. Huh? Get.